Circles and coordinate geometry. In this section, we will be exploring the following: midpoints and perpendicular bisectors, the equation of a circle, intersections of straight lines and circles, tangent and chord properties, circles and triangles. So, as a brief overview of what's coming up in this chapter, here's a line segment. This is the midpoint, which we can see because we've marked either side as being equal in length. This line is the perpendicular bisector of the original line segment. We're going to look at the equation of a circle, both with circles centered at the origin and centered at some other point. We're going to look at the intersections of straight lines and circles. So here we have a circle. Here we have a straight line that cuts the circle in two distinct places. Here we have a tangent to the circle, which touches the circle just at one point. And here we have a line that misses the circle altogether. We're going to look at all of those cases. Here's another circle. Here's a tangent. And here's the center of the circle. One tangent property that we'll look at is that the radius meets the tangent always at a right angle. This time a chord property. So we have a circle in the center here, and this line is called a chord. The diameter is a special chord which goes through the center. If this line bisects the chord, it will go through the center of the circle. If we have a diameter, remember that's a line across the circle through the center, and then we produce an angle standing on the ends of the diameter, and at the circumference, we call this subtended. This is the angle subtended by the diameter. That's always a right angle. The last one that we'll look at here, if we have a circle and a triangle inside the circle, such as the vertices touch the circumference of the circle, this circle is known as the circumcircle of this triangle. So in the same way up here, this is the circumcircle of this right-angled triangle. Now we know from over here that if we have a perpendicular bisector of a chord, that will go through the center. So if we had another one using another side of the triangle, these two bisectors would cross at the center of the circle. We'll go through all of this in more detail as we go through the chapter.